Hello everyone, I'm presenting this video as my final project of the course Wireless Communications of Professor Wu at University of Florida. The topic of this project is channel estimation for OFDM systems. I'm trying to make this explanation simple and understandable to comprehend. The agenda of this presentation is as follows. The first one is introduction, followed by the OFDM merits and demerits, modulation and demodulation, OFDM channel estimation, palette form, and channel estimation methods. The first part is introduction. OFDM is one of the ways in which multi-carrier transmission schemes are implemented. In many literature, OFDM is also called DMT modulation. OFDM utilized inverse fast Fourier transform and fast demodulation respectively. It is a multi-carrier transmission scheme with the lowest complexity and is widely used. The second part is the OFDM demerits and merits. The OFDM system has many merits, like it can send a lot of data in the narrow band. It can continuously monitor the sudden changes in the communication characteristics on the transmission medium, and it also can detect the specific carriers in the transmission medium, and it has a strong anti-fading ability and very resistant to narrowband interference. And this method based on IFFT and FFT can be used. The channel utilization is really high, and it can improve the capacity of the system to transmit information, and it also can be used to achieve an attractive single frequency network. But there also exist demerits of OFDM system, like it is more sensitive to carrier frequency offset and phase noise than single carrier systems, and it has a high PAR, which results in a decrease in the power efficiency of the RF amplifier. Then we'll introduce the demodulation of OFDM. The picture showed a symbol OFDM generation. Each OFDM symbol is the sum of the plurality of modulated subcarrier signals, where in the modulation scheme of each subcarrier may select PSK or QAM, and the following equations can express the OFDM symbol. This is OFDM symbol, which shows orthogonality. The orthogonality can also be understood from the frequency domain. From the spectrum of each subcarrier signal of OFDM, it can be seen that the spectral value of all other subchannels is exactly 0 at the maximum of each subcarrier frequency. Next, we introduce the OFDM channel estimation. Channel estimation is the hot spot in the field of communication, which is the basis for correlation detection, demodulation, and equalization. Due to the emergence of OFDM multi-carriers, this provides a new space for the application of channel estimation technology. Then we introduce the palette. The palette scheme based on palette symbol channel estimation is determined by two important parameters, the maximum speed and the maximum multipulse delay. In order to be able to keep up with the time frequency variation of the transfer function, the palette symbols should be placed sufficiently close, but the palette symbols cannot be too much, which will reduce the data rate. This is the contemp palette form, which are evenly distributed within each OFDM symbol. This palette form has a higher repetition rate within an OFDM symbol, and there are only some subcarriers contain palette signals, and the estimate of the data information channel response can be gotten by the agent adjacent pallet subcarriers, so it is an appropriate option for fast-fitting channels. And it is the block pallet form in which a pallet signal is periodically transmitted within a particular OFDM symbol. This form is particularly suitable for slow-fitting channels since the symbol carries in all pallets. The third one is the scattered pallet form. The pallet signal is evenly distributed in both the time and the frequency direction. It can use lesser number of pallets than the first two forms and has good performance. It can track the channel variety better. Next is OFDM channel estimation method. This is a channel estimation system model in frequency domain. The binary information and the inserted pallet signals are mapped into QAM signals by encoding. And this is the channel estimation system model in time domain. In this manner, the pallet signal is periodically inserted in each OFDM symbol. The response of the channel is estimated using the correlation of the received pallet signal and the PN sequence stored by the local receiver. There is an improved channel estimation system model in time domain. In this algorithm, an OFDM symbol interval is divided into L equal long subintervals, and it is assumed that the multi-pass delay is invariant within an OFDM symbol, and the variation of the symbol amplitude and phase within one subinterval is negligible, and the received signal is divided into two parts, namely long-term fitting and short-term fitting. And then we're drawing conclusion. This paper first analyzes the basic principle of OFDM as an efficient multi-carrier modulation technology and briefly discusses the latest developments, technical advantages and disadvantages of OFDM system and its applications. In order to facilitate the analysis of channel estimation performance, the general characteristics of wireless mobile channels are also analyzed. Based on the estimation of the pallet signals, we must first determine the form of the pallet. In this paper, we discuss the establishment of the interval of the pallet signals in the direction of the time domain and the frequency domain, and analyzes the different pallet forms. Several different estimation techniques are proposed for different fitting channels, and several methods of channel estimations are proposed. And finally, the reference. My presentation is over. Thanks for watching.